Hey, this is Anag, and in this video I will prove that the circumference of a circle is 2 pi r. And a disclaimer, this proof does involve integrals, so if you do not understand integrals, I would brush up on that before watching this video. To prove that the circumference of a circle is 2 pi r, what I'm going to do is that first I'm going to find a formula for the arc length of a semicircle, and then I will double it to get the circumference of the entire circle. But how do we find a formula for the semicircle? For this, we're going to have to use an integral to figure out the arc length. And how do we do that? Let's take a look at this figure on the right, the one that I've drawn with an arrow. Let's assume that we have this arc. And then the blue sliver, let's call that ds. Now, let's make a little right triangle with ds as the hypotenuse. Let's call the horizontal leg dx and the vertical leg dy. By the Pythagorean theorem, we can say that ds squared is equal to dx squared plus dy squared, which means that ds can be rewritten as the square root of dx squared plus dy squared, like that. To find the length of the entire arc, what we have to do is add up all these little ds's over the entire arc. And if we were to write that, we would write the arc length as the integral of ds. The integral of ds just means that you're adding up all of those little ds's. But we established that ds can be rewritten as the square root of dx squared plus dy squared. So this equals the integral of the square root of dx squared plus dy squared. Now let's take the inside expression and multiply it by dx over dx. If we do this, we can see that this integral over here will become, the dx just stays on the outside, and now we can put the 1 over dx on the inside by making it 1 over dx squared times dx squared plus dy squared, the square root of all this multiplied by dx on the outside. And now we can just simplify. We have the integral of 1 over dx squared times dx squared is just 1, plus dy over dx squared, the square root of all this, dx. And if you look back at our arc, we can see that we have to integrate from negative r to positive r. So let's make those two things our bounds. So the integral from negative r to positive r. And this is the integral that we have to find. So now that we have our expression laid out, let's evaluate it. So the first thing we need to know is, what is dy by dx? Well, we know that x squared plus y squared equals r squared. This is the definition of a circle. Now let's use implicit differentiation and figure out what dy by dx is. The derivative of x squared is 2x, plus the derivative of y squared with respect to x is 2y dy dx by the chain rule. And then the derivative of r squared is 0, because the derivative of any constant is just 0. Now we can solve for dy by dx. 2y times dy by dx is equal to negative 2x, which means dy by dx is equal to negative 2x over 2y, which is equal to negative x over y. So if we plug this back into our original expression, we get that the arc length is equal to the integral from negative r to r of the square root of 1 plus x squared over y squared with respect to x. So how do we proceed from here? Here we can actually rewrite the expression under the radical as, so we have the integral from negative r to r, and 1 can just be rewritten as y squared over y squared. So we have y squared plus x squared over y squared, the square root of this dx. From the equation of a circle, we know that y squared plus x squared is the same thing as r squared. So if we have the square root of r squared over y squared, all that simplifies to the integral from negative r 2r of r over y dx. And now we can rewrite y as the square root of r squared minus x squared. That comes straight out of the fact that x squared plus y squared equals r squared. So this equals the integral from negative r to r of r over the square root of r squared minus x squared dx. From here we can see that r is a constant, so we can pull r outside the integral. So this becomes r times the integral from negative r to r of 1 over the square root of r squared minus x squared dx. And how do we proceed? Well, you may have noticed that 1 over the square root of r squared minus x squared matches the form of the derivative of the inverse sine of x, meaning that the antiderivative of expression of this form goes to the inverse sine. So what this means is that this is going to become r times the inverse sine of x over r, and then you got to evaluate this from negative r to positive r. And now it's fairly straightforward to evaluate. Just take a r, and then we take the inverse sine of r over r minus the inverse sine of negative r over r. Like that. So we have r times the inverse sine of 1 is pi over 2 minus the inverse sine of negative 1 is negative pi over 2. Meaning that we have r multiplied by pi over 2 minus negative pi over 2 is the same as pi over 2 plus pi over 2, which just gives you pi. So this is pi r. And this is the arc length of a semicircle. So the arc length of a full circle, or the circumference, is going to be 2 times pi r, meaning that we have just proved that the circumference of a circle is 2 pi r. Thank you for watching this video, and if you want more content like this, please be sure to subscribe. Also drop a like to make me feel better. Thank you.